Welcome to Chapter 3 and Fair Division. This chapter I very much enjoy. Here's the textbook, our free textbook, and the author does an excellent job of listing out what's involved in the fair division method and some of the assumptions. But rather than do that with you, let me just jump in. I'm going to jump down here and tell you a story. So fair division, again, Chapter 3, fair division. What are we doing here? Well, in society, again, this whole course is ways, contemporary ways, current ways math is being used in regular society to help us do things better. In Chapter 1, we saw how it helps us vote better, make better decisions as groups, what to make voting more fair. Chapter 2, we saw weighted voting, how groups that have power, we can figure out how much power they have and to understand power structures in weighted voting systems like the Electoral College and stockholder companies. All kinds of things in real life are that way. Now Chapter 3, fair division. So when you split things up, let me give you my favorite example. I've raised 5 children. 3 of them are in college now, 2 more are getting closer to it. But I remember when my youngest 2 were really young, there would often be like 1 cookie left from some lunchtime event. There's 1 cookie left on the counter. And my 2 littlest ones, Johnny and Abby, both want the cookie. And so I say, all right, you guys go over there and split it. Split the cookie, right? Fair division. Divide the cookie. Split the cookie. Well, that always went terrible because they would have this cookie and one of them would take the knife and they would cut, and maybe it wouldn't be equal, and then there'd be all this screaming and yelling. And then I actually started teaching this class. This was years ago, more than a decade. And I realized a method. So here comes question number 1 in your video quiz. What method I'm going to use? It's called the divider-chooser method. Let me show you how it works. You go back to that cookie and you pick one. So my older, among those last 2, John was a little bit older and Abby was the youngest of 5 in our family. And so what I would do is I say, Johnny, you're going to be the divider, the one who cuts the cookie. And Abby, you're going to be the chooser. This is what I learned. And I actually did it. I'm not making this up, in my own home about a decade ago. And it worked wonderfully. So they'd go over to the cookie, like they'd done many times before. But now they have the instructions. Johnny's going to cut it, and then Abby's going to pick which side she wants after Johnny makes the cut. Do you see the genius of this method? So here's how it played out. You can picture it. This is exactly what happened. Johnny grabs the knife as usual. He starts going down through the cookie, and then he starts to go a little bit off center, a little bit this way, like in the past, which usually resulted in screaming and yelling, and my wife and I would have to, one of the other of us would have to go over and address them. And instead, now with the divider-chooser method, when Johnny started going this way, Abby's eyes got big. She thought, great, Johnny, just go ahead and go like that, and I'm going to pick this part. Because remember, Abby gets the first pick. Johnny's the cutter, Abby's the picker. That's the divider-chooser method. One divides, the other chooses. So do you see? And then, of course, Johnny, being a little bit older, realized the significance of this right away. So here's how it went. It was hilarious. He started cutting. He got off center a little bit with his knife. Abby, instead of screaming and yelling, her eyes got big, like, yeah. And Johnny looked over at her, and he got stressed out. And he came back. And then he was like a surgeon. He was cutting that cookie so carefully. It was surgery on that cookie. And so you see the pressure was on Johnny to be fair. The method, it's actually a math method. The mathematical method forced fairness. It forced a fair division of that cookie, and they both walked away happy. Right? Johnny made the cut to where he thought it was super fair. Abby looked him over both very closely, picked the half she wanted. Johnny got the other half, which he couldn't complain. He cut it. And everybody was happy. That's what we're looking at in this chapter, is methods that force society to do things fairly. And one of the deals is not everybody gets along perfectly. You see, that's always the problem. Let's just say that up front. If everybody loved each other the way they want to be loved, then we wouldn't need this math, right? If Johnny and Abby, my two youngest, had a perfect, they have a good relationship, they like each other, but if they had a perfect relationship back then there would be no need for something. Johnny would love Abby and just want to cut it and give her more even. But the truth is, in society, people are not that way all the time, sadly, and so how can the math help us, even in a hostile situation, to produce fair division? Let me give you a second example. There's one more important issue which you may not have thought about, and that is the fact that, well, let me do it. Let me start with a cookie before I give you these facts. Let's suppose we have a cookie or a cake. That didn't come out so good, did it? Let me try again. All right, and let's have a cake, and what we're going to do is we're going to make half of this thing chocolate. So I'm going to split it down the middle, and this part's going to be chocolate, and this part down here is going to be vanilla. Okay, and we've got Maria. Let's say we've got Maria and Jorge, and it's a big old cake. And let's say it's a $30 cake. They went and bought a $30 cake together, Maria and Jorge, and they're going to split this cake among the two of them. So how can they do it fairly? Now, you might say, well, that's not a hard one. I mean, right away you just grab that cake, right, and just cut it right, boom, right there. Right? And one of them gets the chocolate half, one of them gets the vanilla half, and everybody's good. Well, what if I tell you that Maria likes chocolate 2 times as much as vanilla? So in other words, if you made the cut right here and gave Maria the vanilla half, she would feel she'd been robbed. She would not feel that was a fair division because she thinks there's more value in the chocolate half than there is in the vanilla half. At least that's how she feels. And Jorge, let me tell you about Jorge. Jorge, he likes the vanilla 2 times as much as chocolate. Now, of course, if you know all that, well then, give Jorge the vanilla half, give Maria the chocolate half, everybody's good. And that's true. Again, that same thing as before. I will easily admit that if we all knew each other well and cared about each other as much as we want to be cared about, then yeah, we wouldn't need the math at all. They would talk, they would care about each other. Maria likes chocolate better, she gets a chocolate half, Jorge vanilla. But in real life with inheritances, there's fighting among people when land is divided up after wars or in other kind of voting situations. People are not kind to each other. And so we want the math to come in and help us, even in hostile situations, even when there's no communication. Can it still force fairness? That's what this chapter is about. Well, yeah, so in that case, suppose they don't talk. Maria does not want the vanilla half. What if Maria decides she's going to cut the chocolate somewhere and take chocolate? Now, she's going to cut somehow so that she gets half the value. Remember, she likes chocolate twice as much. So in other words, this chocolate part is worth 2x to her and the vanilla part worth x, because she likes the chocolate twice as much. And the whole cake, 2x plus x, is worth $30. So if you solve that little equation, 2x and 1x is 3x, is $30. Divide by 3, x comes out to be 10. So in other words, this chocolate half is worth 2 times 10, 2 times x. We now know x is 10. 2 times 10, $20 for the chocolate half, and this x is just 10 there. So to Maria, the chocolate half is worth $20 and the vanilla half is worth $10, right? She likes the chocolate twice as much and the whole cake is worth 30 bucks. See how that math worked? I took the 2x and the x, that's because of the twice for chocolate. Added it up to be $30 total price, solved for x. X is 10, plugged in 10 here, plugged in 10 there. 2 times 10 is 20. So to Maria, the chocolate half is worth $20 and the vanilla half is only worth $10. It's vice versa to Jorge, of course, but we're just talking about Maria right now. Okay, so what? What does that mean? Well, what does that tell us then about exactly where Maria would cut the chocolate cake? Where's she going to do it? Well, if she cuts it right in the middle, this part will be worth $10, this part's $10, and the bottom's $10. So if she wants to get half the value of the cake, half of 30 is $15, right? So what Maria could do is cut right this in half, because this part's 5, this part's 5, and this part's 10. And she could say, look, I'll take this part right here, which is $15 to her, isn't it? Because this is 5 and this is 10, and that leaves 5 and the whole vanilla half, which is 10. She would think that's a fair division, wouldn't she? Because she's getting $15 worth of cake in her mind out of the $30 value, half. She's getting half. Do you see how we came up with that? Now, I won't go on. The details will be in the homework, and you can watch the videos. They'll go more slowly than I just did, and you can work stuff out. But I just wanted to put in your mind question number 2 then from the video. Question number 2 is what is this? What's the issue here with the Maria Jorge cake? The issue is different people have different values. You see, that's the trick. We can't just cut whatever in half any which way, because not everybody feels the same about everything. That's what's complex in this chapter, and how we really need some fancy math to come in and help us divide things fairly. Because number one, people are hostile, like my own children when they were younger. So you have to use methods like divide or chooser, where one divides, the other chooses. And the second issue is different people have different values. Some like chocolate better, some like strawberry, some like vanilla. And so you have to find out what they value to make sure everybody gets a fair division according to their value system. You see, that's the real challenge. Anybody can cut something in half. You might think, what a silly chapter. Just measure it and cut it in half. Or you got 3 people, cut it in thirds. What's the big deal? Chapter over. No, not so simple. Different people have different values. So we want a mathematical method that'll allow us to cut up things in a fair way, even when they're hostile. It'll force them to be fair, according to their differing value systems. I should write that in there. They're differing value systems. Everybody likes different things differently. So specifically, the most, I think, powerful example of this that we'll see in this chapter will be the method of sealed bids. And that's going to be useful for inheritances specifically. So when there's an inheritance and you have a bunch of people you're dividing up the inheritance with, it's an excellent method of letting people value things however they value it. Somebody might like one thing better than the other. And in the end, everybody walk away with a fair share, forced to, even if they're hostile, according to their differing value systems. That's what this chapter is all about. You can tell it's going to take some fancy math in a hostile situation to force fairness, like divide or chooser, and to deal with all the facts of differing value systems for everybody involved. That's the